So if we were to ask a kid, like, what set is bigger, the set of the integer numbers that contains 0, plus, minus 1, plus, minus 2, plus, minus 3, and so on, or the set of the natural numbers that contains 1, 2, 3, 4, and so on. What do you think the kid would say? Probably that Z has at least twice as many numbers as N, right? Because for each number in N, that one belongs to Z already, and then we have the mirror image, the symmetric of that number too. So it's a little counterintuitive that actually both sets have the same cardinality. Cardinality means that they have the same size in a way. But size is something strange for infinite sets, so we say that they are in correspondence, that they are equivalent. Okay, but this is something we need to show. It's not obvious. Okay, so this means that there is a bijection from Z to N. Okay, and this we need to find. Okay, the only way to show this is to actually find the bijection and say, okay, this is the rule that puts all the integer numbers in sequence. Okay, so the smart way to do this, you saw the way I wrote. So I could have written the numbers Z, I could have written like 0, 1, -1, 2, -2, 3, -3. Or I could have done like 0, 1, 2, -2, 3, -7. What sounds better? The second one, you were probably thinking that eventually I will forget some number, right? Because it was random. But the first one, I was saying, okay, 0, 1, -1, 2, -2, 3, -3. So it's very systematic. So that's what we are aiming for. Okay. So how do we do that? So what we are going to do is to define a mapping f of k, okay? And we are going to do geometrically, we have here our integer numbers. And so on, okay? And the way we are going to put them is interlaced, okay? So we are going to take 0, 1, 2, 3, and so on. And then we are going to put in between, let's use a different color, the negative numbers. Okay, so this is going to be -1, -2, -3, and so on. But then you could complain, well, what do you mean in between? Okay, so once we do like this, then we renumber the whole thing and say, well, 0 is 1, -1 is 2, 1 is 3, -2 is 4, 5, 6, 7, 8, and so on. And you see what is happening here? All the numbers that are 0, 1, 2, 3, and so on, the positive numbers correspond to odd numbers, and the negative ones correspond to even numbers. So what we are going to do is define 2k plus 1 if k is 0, 1, 2, 3, and so on. And we are going to define 2 times the absolute value of k, okay, if k is -1, -2, -3, and so on. Okay, we do like this. For example, let's say k equals -3. So for -3, we would have 2 times 3 is 6, okay, which coincides with what we were saying. On the other hand, if I have 5 would correspond to 11, so it would be like further down the line. But you see, in this way, we can find any number, we can know exactly where it lands, and we can retrieve it if we need.